test. Okay, so confirm that voice is working. I just didn't notice it previously, so, but did hear an echo for desktop sounds, so yeah. It always takes a certain amount of time to basically confirm that the stream is working. So status is kind of various stuff. Okay, so recently added a shuffle instruction. Well, sort of added this back a while ago, but now I've got around to actually implementing it, though annoyingly enough, like because of a compiler bug and stuff, did kind of break some of my existing binaries, like adding it here, because turns out when doing write shifts, the compiler was previously having this bit set, which it wasn't really supposed to, but and I guess, you know, the instruction set's not frozen yet, so that's sort of part. These small scale breaking changes are sort of still par for the course. But yeah. In this case it was, you know, due to a compiler bug rather than actually due to deliberately breaking something, so yeah. So added a few operations for RGB 555. So, but yeah, for averaging and modulating. There's also yeah, some pack and unpack operations. So basically pack from 32 or 64 bits or unpack to 32 or 64 bits from RGB 555, and also view for RGB 32. And there's an RGB shift right one instruction as well. Which use on these were useful for a little sub project I've started working on. Yeah, so a few new instructions, but not that much else change. They add onto the existing GSV system, sort of. except they're listed under RGB, but not too much difference. Oh yeah, there's also, well, some different packed multiply ops. There were these packed multiply befores, which basically did two 16-bit multiplies and produced a pair of 32-bit outputs, but these ones basically multiply all four, or multiply four 16-bit elements and keep either the low or high half of the result with both signed and unsigned varieties. So potentially like the signed and unsigned multiply and keeping the low result is potentially redundant, since I've not actually confirmed whether these cases generate different results or not. But doesn't this redundancy doesn't really make that much different in terms of cost or the Verilog code, so yeah. You know, if they turn out to be redundant, I can just, ignore this bit or ignore the Q bit and just treat them as equivalent in the decoding, but yeah. I think I already mentioned, yeah, the shuffle op, so yeah. Other than that, my ROTT port is now, well, targets BJX2. So initially I didn't have any assembler, but I ended up, well, fully implementing inline assembler support in the compiler. So that's what this here is. So the C up here, C down here, assembler here. So yeah. So yeah, now there's inline ASM. Sort of. Currently it only really works at the top level. Inline ASM in the middle of a function isn't implemented yet, so that won't work. That's also a more complicated case as well, since then you have to figure out how to marshal between the assembly blob and the actual local variables and other stuff, which is kind of difficult. So, and it's easier to just do inline assembler at top level and have it be functions you can call. So yeah. What kind of funny is, I don't actually have any other assembler for the ROTT port yet, but just for the thing for repacking 8-bit pixels to 16-bit pixels, because that turned out to actually be where most of the time is going at the moment. Like more time is spent basically on transferring the frame buffer to video memory than it is to, well, actually doing most of the other drawing and similar. But which is kind of funny considering the kind of terrible VGA emulation I'm using, but could be worse. Yeah, I partially replaced some of the calls to, like, VGA write and similar with, detecting, special cases, like if it's only writing to a single one of the planes, it'll just bypass that logic and write directly to memory for the frame buffer. But so firing it up. It is a little bit slower because this is emulating at 50 megahertz, so there's this stuff back here, which it turns out is a secret area, but took a little while to find this. Was seeing the messages for that secret area, but like, not actually finding the secret area itself. It's kind of annoying. Not actually running this on the FPGA yet because it's still pretty buggy. Well, besides just general bugginess, it's also possible I could end up with another case where buggy software ends up corrupting the SD card, which has happened before. The message of the time to leave door opening is actually a reference to that area over here. So I can run over here. Actually made it through this time. It's kind of hard at these lower frame rates. Last time I tried it on here, I ended up getting stuck inside one of the blocks and stuff rather than getting crushed, but that prompted me to add a no-clip cheat code, which sort of works as well, but it's actually kind of buggy. So for like short runs of no clipping through stuff, yeah, it can work for that, but just casually turning on no clip and running all through the map is prone to cause bugs and or crashing. Because apparently, like, it turns out, where, like, for example, entities are active and sprites are displayed and stuff isn't actually dependent on directly on where the player is in the map, but actually it seems to be triggered by going through these doors. So it might seem like the doors are just casually, well, being doors that you open and go through, but it seems like somehow in the process of going through that door, yeah, in the process of going through the door, it will actually like well, yeah, cause things to spawn and despawn. Or something. That is another one of those bugs I've noticed is, well, is for whatever reason in the current port yeah, dead enemies are a lot of times still functioning as if they were alive in terms of having a hitbox. So not figured that one out yet. Yeah, so along with that and a bunch of random memory corruptions. But so yeah, memory corruptions are an issue. Had also discovered yeah, like a few of the loops in here were apparently they depended on the random number generator, but they also were capable of getting stuck in an infinite loop in some cases, depending on the actual numbers getting output by the random number generator, and I sort of hacked over that one. Technically that changes the behavior in the demos because it causes enemies to spawn in different locations and similar, but on the other hand, you know, it does avoid like occasional hard freezes due to random number generation, which is, one thinks about it, kind of absurd. Because it seems like, yeah, for the enemy spawning, it'll just, you know, randomly probe various locations in the map that it could spawn an enemy, and then it will random hitbox. But yeah, it'll probe various locations it could spawn an enemy, and then it will be done with that loop once like it has basically picked out locations for all the spawns. But if it so happens that the sequence of random numbers, you know, keeps landing on spots that it's already spawned an enemy in, and it fails to land on spots it hasn't spawned an enemy in, it can potentially like get stuck in an infinite loop just trying different spots to spawn an enemy into, but always coming up with one that it's already spawned at, which is kind of absurd in a way. Particularly at difficulty levels where, you know, it's using up pretty much all of its random spawn spots, trying to randomly spawn enemies. So it's, you know, extended times of just trying to find that one last spot that it hadn't spawned into. So I changed the logic to no longer work that way. Instead of that, it will just sort of generate a list of indices, and then it will shuffle that list and then spawn in whatever spots it happens to have index numbers for. So yeah. So it's a slightly different approach, and on the plus side, it avoids the issue of ever getting stuck in an infinite loop. But yeah, just changes the demo, or changes the behavior of the demo. So okay. Yeah, demos, or demo behavior is now kind of changed, but yeah, not too much of a loss considering apparently the demos were already broken compared to what the proper version was supposed to be, which probably I will not see apart from running the actual DOSBox version. Yeah, as noted, yeah, this is technically the BJX2 port of ROTT running in the emulator right now. So, can be noted, yeah, it's kind of laggy, but yeah, kind of laggy and pretty buggy, but it does technically seem to be mostly working. Appears that guy's already dead this time somehow. Looking at it, ROTT does raise up the issue of like whether or not my thing is actually performing faster or slower than vintage x86 hardware. Because well, apparently this one was a game that more or less required a 486 to run, at least moderately quickly. So I don't know, maybe it's going moderately fast, I can't tell. Oh yeah. Yeah. What if else have noticed there? Yeah. On. Yeah. So what else? Else is there of note? Yeah. Now started working on a possible GL port. Actual C version of the loop is not actually complete, but wrote a mock-up in assembler and stuff like this. So can be noted, this is an assembler logic for actually the color modulated case, so it will load a pixel from a texture and then multiply it by the color, and then we'll store it back to the output location. Considering what it is, it's actually relatively short in terms of the assembler code, and should actually spin or be able to spin moderately fast as well, because well, the main slow instructions in this case are basically the memory load here and the memory store here. The rest of these operations are all, well, single cycle, so basically we got roughly three clock cycles here, and then, well, you know, best case is 3 cycles for the load and store offs. So 6 between these two, 3 between these two, and these operations here calculate the texture position, which would have been the same for either. Yeah. Oh yeah. That's looking, but yeah. So for whether or not Li's doing color modulation or not, the stuff for calculating texture position will have basically been similar. This is basically doing the texture coordinates by using a single register to represent both the S and T coordinate, just sort of shifting the upper half right by 32 bits and then masking both sides and then ORing them together. One could question, well, why do it that way? But and this basically, well, it saves a register and it also is a little bit faster. Oh yeah. So the Y mask, yeah, basically already accounts for the shifting of the register to get, or shifting of the value to, you know, get it well, multiplied by the X coordinate. So yeah. I guess my logic is actually missing a shift here, because it's supposed to shift the X mask right by 16 bits and then AND it. So yeah, that's not quite right. Oh yeah. So shifts the bottom part right 16 bits, shifts the top part right 32 bits, then ANDs the two sides, which now can be done in parallel since the two sides are independent of each other. These ops are independent so the OR can be merged as well, and take time required. Use 6 operations take roughly about 3 clock cycles. So 3 clock cycles here. And 3 more for this move. 3 more here, and 3 for this other move. And roughly call this 5. 5 is assuming that the branch predictor works correctly. It kind of does. So when it correctly predicts a branch, there will still be effectively one cycle that it can't quite can't quite account for. So one cycle branch latency. If it fails to predict correctly, it will be closer to about 5 cycles. So 2 cycles predicted correctly, 5 cycles non-predicted or mispredicted, and works out to roughly about 2.5% or so average case. Typically rounded it to 3 for the emulator's prediction, or for the emulator accounting for it, because branch or modeling the branch predictor is kind of expensive. So yeah. Yeah. So color modulated texture is one case, and then direct texture, which has the same issue, but looking at it, looks like I was using the same registers, so it works. Yeah, one would note that one could note that, like, conceptually, the fractional part of the high half will overlap with the integer part of the low half of the texture coordinate, but actually it's less of an issue than it might seem, because despite there being only like 16 bits of difference, actual fractional part shifts as well. So it leaves enough space for like the integer part of the low half or x coordinate. All done. All done. Okay, so yeah, I had to reload my view of the YouTube screen there to verify that it's working correctly, but it sort of dropped out a bit. Yeah, oh yeah, the texture coordinate, well, it should work, but admittedly a lot of this code here isn't actually tested yet. It's more just me writing down thoughts at this point. But there are some rules for basically which instructions can go into which lanes and so on. So can't just, for example, as convenient as it would be, can't just take all these instructions and make them all parallel, since dependencies between instructions and which ones are allowed where do kind of limit how the assembler can be written. I had looked into like the RGB5 mod operator, which would have conceptually been able to eliminate a few instructions here, like would merge the unpack, multiply, and repack all into a single instruction conceptually, but the issue with that one is partly cost. Yeah, cost is one factor in it. Also is much less generic of an instruction. So for now I've ended up sticking with the original plan of an unpack instruction, a multiply, and then a repack. Which will cost a few clock cycles per instruction, but oh well. Or per pixel. Not actually written up here yet, but tested on paper by writing assembly code on paper, because that's all I could really do at the time. But that yeah, that version, I had done a version that did 2 of these loops like chained together, and that one is able to do a little, or would be able to better parallelize things a little bit and achieve less cost per pixel. But yeah, it's a little bit more of a complicated piece of logic. So so for now, like, I'm going to do my initial test with a slower but only a single pixel per loop version. Actually, a proper GL would need a bit more than this, but this is just my mock-up for now. So you'd need like the ones for the actual, well, all the ones for alpha blending and alpha test, and also for the C buffered versions, but those will be written in later. And then in here is, yeah, the logic for basically walking the edges and drawing triangles. So this logic's a bit more hairy looking, but is it basically, well, this version deals with all the parameters, so it will interpolate along X and the texture coordinates, and also the color space coordinate and the Z position. And also walking a pointer down to the next scan line. So here it just sort of walks the pointer down one scan line at a time for each step, and offsets by the current starting X position to get the buffer positions to pass to the span drawing function. This does save the span drawing function from having to calculate some of this stuff, which is, kind of relevant, but partly is because that logic has to be, or some of it's going to end up being written in assembler, and with assembler logic you don't want to have too much extra stuff going on, because that makes it harder. But yeah, and you just sort of want the minimum you can get away with generally. As can be noted, the draw span functions are going to be using an array for parameters. So there's a parameter array. This, from my estimate, is probably the least evil for the situation in terms of like both cost and and difficulty of writing and maintaining the assembler code. While you could pass the while it's possible to pass the values via the context, that has the difficulty that basically it's more annoying to access structure fields via assembler code. And similarly, it's not as practical to pass everything via arguments, because for one reason, which actual arguments will be needed by which drawSpan function will depend on the drawSpan function. Secondly, there's there will be too many to effectively fit in or to effectively pass in registers. So the best case would end up, still with a whole bunch of stack arguments for passing for passing a lot of parameters that will only be needed by certain draw span functions. So between those various possibilities, passing an array for all the dynamically changing parameters made the most sense. And it can be noted here, it's, just sort of sets them to the position and step parameters for each scan line. These step parameters would be for within the span, but they're separate from the step parameters used for walking along the edges. Basically, I guess it could be considered an H configuration, because you have the two left and right rungs of an H-shaped ladder and stuff. You walk down the two sides, and then you have the interior rung, or the interior thing between the two sides, which would basically be the draw span. Effectively, you just change the configuration of the two edges depending on the shape, between the left and right edges depending on the shape of the triangle. You can also technically handle quads as well if quads are supported. And triangle drawing function, it's kind of a mess in terms of calculations, but it will do this mess and then generate parameters for basically the edges and then walk along those edges. At least in terms of a mock-up, this is all untested, but should probably work. And it's not the first software renderer I've written, so it's probable that I've not screwed up anything too major. Oh yeah. But writing it clean mostly because I am trying to figure out the most efficient way I can do it on this architecture. Oh yeah, another example of scaling a color by reciprocal. The actual C version, some bit twiddly mess of breaking it out and multiplying it and then recombining it, whereas the assembler version, it's essentially two instructions here actually doing the logic, so it basically just shuffles the second parameter to have it fill all the elements or all the word elements of the register, and then it does a packed multiply to multiply the two vectors against each other, and then sends that to the return value register. And then it's done. So two instructions doing actual work, and then a third simply returning from the function. In a way, that's a useful property of semi-useful property of doing the simmed via the GPRs. So don't need to have, separate register wrangling to get things, well, from the GPRs over to the SIMD register or vice versa, and so on. And you can also share a lot of instructions between the integer path and the SIMD path. The one for calculating the reciprocal for a count is actually just sort of placeholder logic for now, because actually just straight up doing a division like that's actually fairly expensive. So that's like part of the to be replaced later logic. Different ways it can be done. Like one generic strategy for doing like reciprocals like this is you can use a lookup table, but lookup tables aren't super fast on this ISA either, so it's a trade-off. Another one that curiously happens to actually be a little bit faster on this instruction set is to basically handle all the small value cases by essentially using a switch block and stuff. So switch block over to the logic for dividing the particular variables of in interest and returning that. But yeah, granted, obviously enough a switch would be a slower option on x86, but something like x86, but on this case it happens to actually be a little bit faster than the lookup table option for some reason. But the great limitation of using a switch is that it doesn't scale very well, so it only really works effectively for a small number of cases. So yeah, and probably won't work out very well in this case because the typical span for the triangle is larger than the cutoff where that's an effective strategy. So yeah, so it's most likely going to be a lookup table. So as noted, the draw span and also the edge walking function will probably both be via function pointers in the context. This is because well, which of the functions you're using will depend a lot on the properties, the geometry that's being drawn is set up for. But yeah. Okay. So this is a much older software render of mine, or an older OpenGL implemented in Solver, but as can be seen, the logic for this one will, yeah, it's kind of a bit less efficient. Yeah, at least in terms of the draw span loops, but so in this case, yeah, it's we're using direct divisions and stuff, but also calculating the step parameters and other things like that within the draw span function. And well, you know, packing, and it's also doing all the multiplying and like packing and other stuff like that via discrete scalar code. So my older GL was, you know, not particularly efficient compared with what I'm attempting to pull off on BJX2, but if the one I was doing on BJX2 was as slow as this one was, then my whole effort would effectively be doomed already. But even despite how inefficient this older attempt was, it was still actually fast enough to run Quake 3. Annoyingly enough, I don't seem to have the debugger still running for Quake 3, but mouse. Oh yeah, got captured. But so set it to a tiny resolution, partly to simulate yeah. See if I can make that a little less noisy. Actually, I'll probably totally disabled sound because for some reason I've noted apparently the background music in Quake 3 actually seems to get copyright claims for some reason, which, yeah, that makes no sense to me, but some of my past videos have got claims on them due to apparently the Quake 3 background music. Yeah. As noted, yeah, it's not really as obvious with this really small window, but yeah, there is some texture warping and other things that go on with this. Partly that's a side effect of basically the a fine texturing that thing is doing. So it's, yeah, doesn't use perspective correct texturing, so I had made it smaller as a test, but it can actually handle much higher resolutions than this. To see if I still have the config file open. And it doesn't look like it. Probably change it to a higher resolution here so I can actually see stuff. Probably good for now. But of course I have to exit in order to change the config file. So whenever the resolution is changed in Quake 3, it automatically defaults back to the hardware rendered OpenGL, so that's why I have to do that. edit the config file to get it back to my version. Oh yeah, lots of texture warping. But, yeah. But as noted, this is, Quake 3 running, in a software, or Quake 3 running in a software renderer, so, yeah. And arguably not a particularly good one either. So, yeah, and it does actually try to fake the effects of trilinear filtering to some extent. So, it's not nearest filtered. Whereas the one I'm probably going to be doing for my BJX2 GL will probably be nearest filtered. As yeah. As noted, like, yeah, this particular software GL was something I wrote about 6 years ago or so now. So, yeah. And it can handle decent resolution on a modern PC, but it's because a modern PC has a semi-fast processor, whereas my BJX2 core does not. So it'll be running at 50 megahertz, and everything has to be a bit more efficient to actually have much chance at well, running. Fire up a different map. Oh yeah, the fog effect basically works. At least in this version. And that effect is, well, being done by Quake 3 itself. So, oh yeah, that's not an issue. I was probably going to copy and paste a few bits of code from this older software GL into my newer one, but yeah. Well, yeah, some of the stuff related to the OpenGL API and stuff like that, I can probably copy paste, but most of the rasterizer logic I'm going to be writing specifically. See if I can find another map with interesting stuff going on. It's a map, I think it is. This is, of course, running Quake 3 in vertex lighted mode, which makes it faster, but disables some graphical features. This is, of course, not the map I was intending to go for, but it's been a while since I messed with this. This particular map, at least in the past, like, was notable mostly because tended to cause some pretty severe lag with the software GL. Guess I could go and turn on the fancier graphics. So and it, of course, changing the settings has gone and switched it back over to the hardware GL, which I don't want. So if I do a BJX2 port of Quake 3, I'm probably going to, change that. Well, actually, if I do a BJX2 point, that'll be kind of moot anyway, since the default GL would be my custom GL. But I could modify it technically if I went and found the code for that. So go back here. Oh yeah, this is technically the fancier graphic mode. And as can be noted, performance on this map is not particularly great. It has noted, yeah, this is, well, already noted this is, just software rendering. So yeah. Software rendering within, as I realize now, not particularly good software renderer, but yeah. But yeah, technically a better software GL would have, probably been using SSE and all that other fun, as opposed to, a bunch of scalar, or it's a bunch of scalar code. But yeah. But my old software GL, well, it's still technically running Quake 3 semi-acceptably, despite, being a whole bunch of scalar code. And other maps perform better than this. Don't remember what this map is right now. Oh yeah, I think I remember this map. Maybe. Yeah, it's not quite the map I thought it was. But yeah. It's a small map with not that much interesting going on to look at. Yeah. Yeah, I think DM14 was the one I was thinking, maybe. This is another map I tested with a bunch because it has some more interesting graphical stuff going on. But and also another one that was worked reasonably okay as a stress test. Wondering what my CPU load is like running this. Now, So it's either Quake and or my past code has apparently figured out a way to get past the 9% CPU load limit. So something I've noted before. It's all like my other tests. I try to spawn multiple threads, but it seems to keep getting stuck at around 9% CPU load and not going beyond that, like, you know, no matter how many threads I create. But this is, you know, operating it, you know, closer to about 16% CPU load. So it's, you know, almost double. Technically, like, this software GL did, this software GL did technically utilize multiple threads, so, yeah. Well, it used multiple threads and stuff, but, you know, might have to look into it. Figure out why this one is seemingly being able to use more CPU load than some of my other programs, but, yeah. Or being able to cause more CPU load and not get stuck on, like, 2 cores. Yeah. Yeah, it gives a general idea of something. As noted. Yeah. The yeah, the old, like, one, yeah, it's basically has a bunch of stuff implementing the front end version of the OpenGL API, which is what Quake is using there, or Quake 3 is using there. But you know, probably attempt to reuse some of this. As yeah, a lot of this stuff here is less speed critical, and I can only really, or will probably mostly focus on the speed sensitive parts in my other port. But then again, on a 50 megahertz CPU, pretty much everything's going to be speed sensitive, so, but we'll see. As can be noted, it partly in my favor is it will be operating at a somewhat lower screen resolution, so it should make it hopefully easier. that was one of my first software GLs, but I also have another one which was more specialized, but I had it for my this is looks like another copy of the previous one. This was another much smaller software GL, which was used as part of my second 3D engine, but as noted, most of the OpenGL functions are actually just sort of stubs in this one. Supposed to, just trying to support all of OpenGL. This one just sort of implemented the parts that were being used by my BJX2 engine. As can be noted, this version, it's also mostly scalar code. And technically some rather large and hairy looking draw spam loops as well. But yeah. And it did, technically work. I don't remember offhand if this is currently set up to use my software renderer or hardware GL. See about this. Actually, been a while since I messed with this. I'm gonna check something. Yep. Okay, yes. This is clearly not working right. So yeah, well, I guess could demonstrate it, but clearly something is broken. But I can note that I hadn't messed with it much recently, so it, well, even if the even if the hardware OpenGL has changed, my it should have been working, or it should have been working with the software renderer, but clearly it is not. if that makes a difference. No, it has not. Well, I guess, you know, ruins one thing I could demonstrate, which is, yeah, could have demonstrated my 3D render, or my 3D renderer using my software GL, except it seems to have broken for some unknown reason. I guess such is the power of bit rot. Actually, I think I have an idea. I think if I remember correctly, I might have at some point rebuilt it like the 64-bit when I was attempting to debug something else, and I think because of DLL issues, it might need to be 32-bit. See if the software renderer wants to work. No, it does not. But now it's 32 bits, so maybe I can try. I'll want no VBO and no shader for that one. See if this works. Doesn't appear to. So, So I'll have to conclude that my 3D engine has broken for some unknown reason, since probably the last time I messed with it. But, which was kind of a while ago. Yeah. Well, that's kind of annoying, but yeah. Yeah, if I do attempt to do a BJX port of Quake 3, which is possible, I have noted I will need to, yeah, I probably will need to, you know, do virtual memory for that. It says I'm still uploading, but my view of my live stream has effectively died off, which I'm trying to figure out. Here's I'm in some sort of internet limbo right now. OBS says I'm still uploading, but Nothing else appears to be working. It's like I have to go on faith that I'm still uploading or still streaming. Okay. My ability to see my own stream has been restored, and so confirming that I'm still online. Oh yeah, so the point being, yeah, the BJX2 GL will not using scalar code, so it'll be different. And also a difference will be it's not going to be doing a bunch of memory allocated triangles and spans and similar, because that turned out to actually be a relatively not good idea in retrospect. As turns out, like with memory allocated spans, you end up wasting a lot of time with cache misses and stuff accessing the span, and that was noticeable even on x86, so probably won't do it that way. I was going to talk about something else as well, but I got distracted and kind of forgot. Yeah. Yeah, for now this is still pretty incomplete, but might do something. Oh yeah, virtual memory. Yeah, but yeah, for Quake 3, and stuff, it ends up using more RAM than I actually have in my FPGA board, so we'll need virtual memory for that, support for that to work. So, but haven't gotten around to actually implementing or testing support for support for that yet. So I don't know yet if the MMU will actually work. But probably will need to test and confirm it at some point. But in this case, it would be probably using a big swap file on the SD card or similar as its paging file. Then as opposed to being limited to like the 128 megs actually on the FPGA, I'll probably be able to have like 2 gigs or something. Trying to determine if there's anything else I need to I should probably mention right now or not. But yeah, but otherwise, yeah, trying to get ROTT building on my custom C compiler. Encountered a few. It did like point out a few bugs, but not that many obvious compiler bugs that I found thus far yet, or identified thus far yet. Apart from some general bugginess in the game, which I've not yet found the causes for those bugs. So I don't know if they're compiler bugs or something else. Yeah. Yes, with all the, with 2 cores and with all the simmed and stuff, I'm now up to 88% resource, or yeah, using 88% of the LUTs, but yeah. And the recent addition of, you know, packed multiply to all the execute lanes and some other stuff like that has increased the DSP cost a fair bit, but still, like, still DSP units are something that FPGA seemingly has more than enough of, so that's not an issue. And it's using, well, 7 of the 32 possible buffers, but not that much interesting or new to demonstrate on the actual FPGA at the moment. I could always, like, yeah, would be left mostly to running Doom or Hexen or Quake or similar, but pretty much everyone's already seen that, and most other recent additions haven't resulted in anything visually notable. So yeah. And some recent additions have made Verilog simulation a lot slower than it was before, which is kind of annoying. Now, as opposed to the previous, like, roughly 1,000 times slower, it's like closer to 2,000 or 3,000 times slower. Yeah, and I've already noted this stuff. So yeah. But yeah, short of my still ongoing ROTT porting effort and a possible Quake 3 port, depending, and a possible GL or GL backend. Yeah, I think I probably noted everything, or everything I was going to talk about. Feeling I think I remembered putting comments somewhere of stuff I was going to talk about. span and everything is parameters via arrays. Yeah, I think I mentioned this already, namely structures are annoying to access from assembler code, so arrays. And globals are also more expensive to access from assembler code, so also arrays. Yeah. Well, in this case, it's not like I'm using GOTS or anything, so it's not quite as bad as it would be with ELF, but it's still more expensive than a simple direct access, as would be used for accessing a structure or an array. So those are a little bit cheaper to access than, or still a little bit cheaper to access than globals. So and yeah, also I'm going to be using RGB 555 pixels for everything. I think, yeah, last week I mentioned the alpha encoding scheme this will be using. Yeah. The instructions I added to the CPU to some extent are familiar with the alpha encoding, so it will use the alpha bit pattern when doing the pack and unpack operations. And some of these ops I've also added to the emulator as well. So yeah. So yeah, probably all for now.